Hello everyone, my name is Suman Sharma and right now I'm preparing for my technical mechanical engineering exams and simultaneously I'm recording the video session for SOM, that is strength of materials. We will cover, as you can see, these are the topics we will cover in the particular subject. First one is stress and strain, second one is elastic constants. Third one is Poisson's ratio. Fourth one is Moore circle. Fifth one is thin cylinders, shear force, bending moment diagram, water bending and shear stress, concept of shear center, deflection of beam, torsion of circular shafts, pilot theory of columns, energy methods, thermal stresses, strain, causes and rocks, testing of materials with universal testing machine, testing of hardness and impact strength. So here we can start the subject. This is the what is so what is strength of materials. Here we can see SOM is the study of the internal resistance forces development during the elastic deformation of body when subjected to external load. Basically, SOM is a study developed during the elastic deformation, not in the plastic deformation. It is the internal resistance of a body which occurs in the elastic deformation. So there are two types of deformation. Here you can see. First one is elastic deformation, and second one is plastic deformation. What is elastic deformation? Elastic deformation is a deformation where, for example, we can take example of rubber. So rubber is the elastic material, not a. We can rubber is the option of elastic material. Elastic material, like you can stretch the rubber and it can regain its shape and size again. Okay, so that is the elastic deformation of a body. And what is the plastic? Plastic deformation is the permanent. If you stretch whatever we can see, if we stretch a steel bar in the universal testing machine or tensile testing machine, then it will particularly the shape, it will increase the length. So uh, so before SOM or strength of material, we have a basic knowledge of mechanics. What is mechanics? Mechanics, it is the oldest physical science that deals with the both moving and stationary bodies influenced by forces. Bodies, there are two types. Again, there are two types of bodies. First one is rigid, deformable, rigid, and second one is deformable. Okay, and mechanics, there are two parts as here you can see. First one is rigid body, second one is deformable body. If we talk about rigid body, again the rigid body has two parts: engineering mechanics and tone. Tone is theory of machines, and second one is engineering mechanics. In deformable body, there is solid and fluid mechanics. Okay, if we talk about the solid, there are there is one type is static, so as an uh, TOE, theory of elasticity, MODB. Okay. The second one is dynamic correlations. So here you can note, basically these are the notes that I'm reading. Uh, uh, Even this is my basically a first revision I'm putting on the YouTube. So if you have any doubt, you can ask me on the mail ID. I will share you my mail ID. If you want any type of lecture, you can contact me on this. Okay, so there are mandatory three S's. Three S. What are the three S? First one is stress. Second one is strain. Third one is stability. Okay, what is stress? Basically, I'm just giving you an idea. What is stress? Stress is the force acting on an area. Okay, the force acting on an area is called the stress or the strain. The strain is basically the strain is the ratio of a change in length upon original length. Okay, what is stability? The body have to be stable. Third one. Okay, uh, rigid body. Basically, it can't exist in real cases. If we talking about the rigid body like wall. Here you can see wall is also can be called a rigid body. But if there is a bar, prismatic bar, I am stretching the prismatic bar. There is no change in the intermolecular distance. There is no change in length. There is no change in the dia of the particular bar. So that we will call a rigid case. It is a hypothetical situation, not a real situation. Okay. What is resistant body? Uh, a body which show rigid behavior up to the certain amount of external load is called a resistant body. A resistant body practically exists. Wall mountains, retaining walls, mountains, dams, etc. Okay. Rigid body as hypothetical case. Resistance body is different thing. Okay. Another when we go further for the deformable body. Deformed body, if there is a prismatic bar, you are stretching a bar. That is the tensile force P acting upon it. Okay. Then length will be original length plus change in length, and the D will become up D dash. Tick. Okay. So D is not constant in that particular case. L is not constant. Basically, you can feel the change. Okay, the L will increase, the D will get shorter. Okay, dimension change will be there. You can see in term of diameter, in term of length. Okay, fluids. If we're talking about fluids, fluids are not resistant body. Basically, the notes prepared by one of my online teacher, and I'm just recreating them. Thanks very much. And I think we just completed for today, and we will discuss in the next video. And the next topic will be elastic. We will talk about elastic deformation. What are the plastic deformation manufacturing? What is the aim? And the further topics will be discussed in another video. And thank you very much. If you find any type of mistake or any type of error in the video, if you want to improve, if you want to improve in teaching, in my teaching, or in my just guidance, you can see, not a teaching, proper teaching. I'm just explaining it to you. Okay, if you know any type of concept, I'm just sharing my notes to you. Basically, this video purpose only. And simultaneously, I'm also preparing for the exams. So hope we'll meet you in the next video. And Thank you very much for your support. Tata for today.